Operation and control of light show drones. Light show drones are sophisticated unmanned aerial vehicles, UAVs, designed to perform complex, synchronized flight pattern while emitting colorful LED light displays. Operating and controlling these drones requires a precise combination of software programming, radio communication, flight control, and safety measures. This guide will present a comprehensive process for effectively operating and controlling light show drones. 1. Understanding light show drones. Before operation, it is important to understand the components and capabilities of light show drones. LED system, high-intensity LEDs with multiple colors that can change colors, blink, and create dynamic light effects. GPS module allows the drone to accurately follow pre-programmed flight paths. IMU, inertial measurement unit, maintains flight stability and orientation. Radio transceiver communicates with the ground control station. Battery provides power for flight and lighting systems, typically lasting 15 to 25 minutes per show. Microcontroller, flight controller, manages flight commands, coordinates lighting timing, and executes mission data. 2. Preparation before the flight. Mission planning. The most important part of operating a light show drone is mission planning, where each flight path and drone light pattern is pre-programmed. 3D animation software. The operator uses specialized software, e.g. drone show software, Blender plugin, to choreograph drone movements and light effects. Waypoint programming. Each drone is assigned a sequence of GPS waypoints, timing information, and light animation triggers. Collision avoidance. Routes are designed to prevent drones from crossing paths or flying too close to each other. Simulation testing. The entire program is virtually simulated to check timing, accuracy, and synchronization. Software and hardware checks. Update drone firmware and verify compatibility with the show software. Inspect propellers, motors, LEDs, GPS antennas, and power systems. Calibrate sensors, compass, gyroscope, accelerometer, batteries, and charging. Fully charge all drone batteries. Label and track batteries to manage power performance and prevent sudden shutdowns. Environmental assessment. Check wind speed, ideally below 10 to 15 km/h, visibility, and potential signal interference. Ensure GPS signal strength is sufficient. Create a geographically restricted area free of obstacles, people, or hazards. 3. Setting up the ground station. The ground control station, GCS, is the central command system for monitoring and launching the drone fleet. Control computer runs mission control software and connects to each drone via a wireless network. Radio antenna, used to send control signals and receive telemetry data. Base GPS station, optional RTK, provides real-time kinematic corrections for centimeter-level accurate positioning. Wi-Fi/radio module ensures communication and real-time data updates. Deployment and positioning. Each drone is manually placed on the ground at a predetermined starting coordinate marked by GPS. Use ground markers or QR code mats for precise orientation. Ensure the drones are spaced sufficiently apart, usually 1.52 meters. Perform a pre-flight test run for small segments of the program. 5. Flight operation and launch sequence. Activate the flight team. All drones are activated simultaneously via the control software. Perform system checks, GPS lock, battery voltage, compass calibration, Confirm green status for all drones before launch. Launch command. Drones take off in batches or simultaneously depending on the design. Each drone ascends vertically and transitions to the assigned altitude and flight path. Conduct the flight. Each drone flies independently but follows a synchronized timing procedure. Light patterns are activated based on flight position and mission progress. Real-time data transmitted from each drone is monitored, including altitude, speed, position, battery status, signal strength. 6. Light control and synchronization. Coordinated light performance. Light effects are embedded in the drone's mission data. Precise time synchronization using GPS time or NTP server ensures all drones change colors or blink in sync. Pattern transitions. Drones form complex shapes, logos, animations, text, by occupying specific GPS positions in 3D space. Transitions between shapes are smooth and choreographed using spline curves. Error handling during performance. Automatic return to home, RTH. In case of low battery, signal loss, GPS error, manual control via GCS is possible if necessary. 7. Landing procedure. The performance ends with a landing maneuver integrated into the mission. The drones land sequentially or in groups to avoid turbulence caused by downdrafts. After landing, each drone will deactivate and switch to standby mode. 8. Post-flight tasks. Data collection and diagnostics. Retrieve flight logs and diagnostic data to analyze performance. Check for errors, abnormalities, or issues in the LED strip or flight path. Maintenance. Inspect the motor, LEDs, propellers, and battery condition. Replace damaged parts. Clean and store the drone in the protective case. 9. Safety and regulatory compliance. Operating a drone light show fleet must comply with national and local aviation laws as well as safety procedures. Comply with regulations from the FAA, USA, CAC, China, EASA, EU, for commercial drone shows. Obtain flight permissions, issue NOTAMs, notices to airmen, and event organization permits. Maintain a safety zone, monitored by ground staff to ensure crowd safety. Prepare emergency response plans, fire extinguishers, and first aid kits. 10. Roles and responsibilities of the team. A successful drone light show usually requires a team with specialized roles. Role responsibilities. Flight director. Oversees the entire operation and executes the show. Drone. Technician. Prepares, maintains, and recovers the drones. Software engineer. Creates animation files and manages the show script. Ground station operator. Monitors flight status and initiates takeoff, landing safety officer. Ensures compliance with regulations and crowd safety observer, supervisor and monitors drone behavior from the field. 11. Common operational challenges. Operating a light show drone team faces challenges that require experience and contingency planning. GPS drift. Use RTK GPS systems to improve accuracy. Signal interference. Apply robust mesh networks and dual-band radios. Battery depletion. Maintain backup time in mission schedules and use reliable power sources. Weather conditions. Postpone the show during rain or strong winds. Synchronization delay. Rely on precise time stamping and redundancy in timing protocols. 12. Scaling and coordinating multiple drones. Small program versus large program. Small program, 20 to 50 drones. Easy manual setup. Usually only requires one ground control station. Large program, 100, 1,000 plus drones. Requires multiple ground stations, advanced fleet management software, and additional logistics for transport and deployment. Advanced synchronization tools. GNSS RTK base station to enhance positioning accuracy. Backup communication links and backup systems. AI-assisted flight planning to optimize space usage and reduce collision risks. Conclusion. Operating and controlling a drone light show requires meticulous planning, precise technical skills, and seamless coordination. From pre-flight checks to real-time monitoring and post-show maintenance, each step plays a crucial role in ensuring safety, visual effects, and technical success. By mastering flight control software, understanding drone behavior, and adhering to safety procedures, operators can deliver spectacular aerial performances that harmoniously combine technology and art.